Hello viewers, welcome to our channel Career Prep. In this video, we'll learn about the concept of speed, time and distance. The concept of speed, time and distance is used extensively for questions relating to different topics such as motion in a straight line, circular motion, trains, boats and streams, races, etc. This topic is an essential part of the quantitative aptitude segment of many competitive exams. The questions from this topic may seem to be confusing and complicated, but once you understand the concept well, you can easily answer and score marks for these types of questions. Since questions based on this topic are most frequently asked in competitive exams, it makes sense to understand the concept well. These questions are the ones where marks can be scored easily if practiced well. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Let's understand the meaning of speed first and then learn about the formula for speed, time and distance. So what is speed? The rate at which an object is moving is known as its speed. Speed is the distance traveled per unit time. For example, an object moving at 20 meters per second shows that the object covers a distance of 20 meters every second. Now let's learn about the formula for speed, time and distance. The formula for speed is equal to distance divided by time. From this formula, you can derive the formula for time and distance. So time is equal to distance divided by speed and distance is equal to speed multiplied by time. Remember these three formula which will help you to solve problems on speed, time and distance. Now you should know that speed is directly proportional to distance and inversely proportional to time. This means that speed is directly proportional to distance. This means that if speed is increased, then the distance traveled will also be more for a particular period of time. And if speed is reduced, then the distance traveled will also be less for a particular period of time. So speed is directly proportional to distance. Now speed is inversely proportional to time. This means as the speed increases, the time taken will decrease and vice versa. That is, if the speed is increased, then the time taken to cover a distance will decrease. Similarly, if speed is decreased, then the time taken to cover a distance will increase. Let's learn about the units of speed, time and distance. The correct usage of units is important while solving problems on speed, time and distance. Now the units for time are seconds, minutes, hours. Units for distance are meters, kilometers, miles, feet, etc. Units for speed are meters per second, kilometer per hour, etc. So, if distance is in kilometers and time is in hour, then since speed is equal to distance divided by time, the units of speed will be kilometer per hour. Speed, time and distance conversions. Now this is a very important concept while solving problems on speed, time and distance. To convert from kilometer per hour to meters per second, we multiply with 5 by 18. So 1 kilometer per hour is equal to 5 by 18 meters per second. Supposing you have to convert 10 kilometers per hour to meters per second, then multiply 10 with 5 by 18. To convert from meters per second to kilometers per hour, we multiply with 18 by 5. So 1 meter per second is equal to 18 by 5 kilometers per hour. Supposing you have to convert 100 meters per second to kilometers per hour, then multiply 100 with 18 by 5. 1 kilometer is equal to 1000 meters, which is also equal to 0.6214 mile. 1 mile is equal to 1.609 kilometer. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. Since 1 minute is equal to 60 seconds, 1 hour is equal to 60 multiplied by 60, which is 3600 seconds. Let's learn about an important concept, inverse proportionality of speed and time. Speed is inversely proportional to time when the distance is constant. So when speed increases, time decreases and vice versa. This means that when speed increases, the time taken to cover a certain distance decreases. Supposing speed is decreased, then the time taken to cover the same distance increases. If the ratio of the speeds of A and B is A is to B, then the ratio of the times taken by them to cover the same distance is 1 by A is to 1 by B or B is to A. Now 1 by A is to 1 by B is nothing but 1 by A divided by 1 by B, which gives us B is to A. So if the ratio of speeds of A and B is A is to B, then ratio of the time taken by them to cover the same distance is B is to A. Now let's understand the concept of average speed. Average speed is equal to total distance covered divided by total time taken. For example, if a car travels 20 kilometers in 1 hour and 60 kilometers in the next 2 hours, then average speed of the car is equal to 80 divided by 3 kilometers per hour, because the total distance covered will be 20 kilometers plus 60 kilometers, which is 80 kilometers. Total time taken is 1 hour plus 2 hours, which is 3 hours. So average speed of the car is 80 divided by 3 kilometers per hour. When the distance is constant, then average speed is equal to 2xy divided by x plus y, where x and y are the two speeds at which the same distance has been covered. For example, if a car travels 25 kilometers at a speed of 20 kilometers per hour and the next 25 kilometers at a speed of 30 kilometers per hour, then the average speed of the car is equal to 2 multiplied by 20 multiplied by 30 divided by 20 plus 30 kilometers per hour. Observe here that the distance covered is 25 kilometers in both the cases. So the distance covered is constant. Only the speed is different. When the time taken is constant, then average speed is equal to x plus y divided by 2, where x and y are the two speeds at which traveled for the same time. For example, if a car travels at a speed of 20 kilometers per hour in the first 3 hours and at 30 kilometers per hour in the next 3 hours, then the average speed of the car is equal to 20 plus 30 divided by 2 kilometers per hour. Observe here that the time taken is constant in both the cases. It is 3 hours in both the cases. Only the speed is different. So the average speed of the car is 50 divided by 2 kilometers per hour here. Let's understand the concept of relative speed. Relative means in comparison to. Thus, the concept of relative speed is used when two or more bodies moving with some speeds are considered. Relative speed is the speed of a moving body with respect to another moving body. Thus, in a problem, whenever you encounter two or more bodies moving with some speed, the concept of relative speed has to be applied. It is very important to understand clearly the working of the concept in the following cases. Two bodies moving in the same direction. Two bodies moving in opposite direction. Let's now learn about the relative speed of two bodies A and B when they move in the same direction and when they move in opposite directions. So let's suppose there are two bodies A and B. Speed of A is V1 kilometers per hour. Speed of B is V2 kilometers per hour. Now when A and B move in the same direction, that is A moves with a speed of V1 kilometers per hour in this direction and B moves with a speed of V2 kilometers per hour in this direction. So after 1 hour, A will be at this position and B will be at this position. So after 1 hour, A and B will be uh, V1 minus V2 kilometers apart. V1 minus V2 kilometers apart. That is, their relative speed is V1 minus V2 kilometer per hour. Now supposing the distance between them is d kilometers, then time after which the two bodies meet is equal to distance divided by relative speed, which is nothing but d kilometers divided by v1 minus v2 kilometers per hour. Now supposing the two bodies are moving in opposite directions. Here A is moving with a speed of v1 kilometers per hour in this direction and B is moving with a speed of v2 kilometers per hour in this direction. So after 1 hour, A will be at this position and B will be at this position. So after 1 hour, A and B will be v1 plus v2 kilometers apart. That is, their relative speed is v1 plus v2 kilometers per hour. Now, if the distance between them is d kilometers, then time after which the two bodies meet is equal to distance divided by relative speed, which is nothing but d kilometers divided by v1 plus v2 kilometers per hour. So, when two bodies move in the same direction, then time after which the two bodies meet is d kilometers divided by v1 minus v2 kilometers per hour. If the two bodies are moving in opposite directions, then time after which the two bodies meet is equal to d kilometers divided by v1 plus V2 kilometers per hour. Here are a few points to remember on relative speed. The concept of relative speed is particularly important for problems based on trains and meeting points. When two bodies are moving in the same direction, then relative speed is calculated as the difference of the two speeds. When the two bodies are moving in opposite directions, relative speed is calculated as the sum of the two speeds. Now let's understand the concept of early, late and usual time. If late and early times are given in any combination in a problem, then to obtain the difference of the times, add the times if it is late early or early late. Subtract the times if it is late late or early early. You have to add the times if the times given are different, like late early or early late. You have to subtract the times if the times given are the same, late late, early early. This is a very important concept to remember for solving problems on early, late and usual times. So add the times if the times given are different, late, early, early, late. Subtract the times if the times given are the same, late, late or early, early, to obtain the difference of the times. For example, a man reaches his office 20 minutes late if he walks from his home at 3 kilometers per hour and reaches 30 minutes early if he walks 4 kilometers per hour. How far is his office from his house? Now you can see here that in the first instance, late time is given, and in the second instance, early time is given. So it is late and early. The times are different, late time and early time. So you have to add the times to get the difference of the times. So 20 plus 30. Supposing in the first instance late time was given and in the second instance also late time was given, then to obtain the difference of the time, since it is late time and late time, you have to subtract the times. So 30 minus 20 to obtain the difference of the times. Let's understand the concept of meeting points. Meeting points is another important concept in the topic speed, time and distance. If two persons A and B start at the same time from 2 points P and Q towards each other, and after meeting they take T1 and T2 hours to reach Q and P respectively, then A speed divided by B speed is equal to square root of T2 divided by square root of T1. Now supposing A starts from the point B in this direction and B starts at the same time from point Q in this direction. They'll meet at this meeting point, and after meeting, A takes T1 hours to reach Q, whereas B takes T2 hours to reach P. Now A speed divided by B speed is equal to square root of T2 divided by square root of T1. Remember this formula for to solve problems of this type in meeting point problems. Now let's understand another important concept in meeting points. If two people travel from 2 points A and B simultaneously towards each other and they meet at point P, the total distance covered by them on the meeting will be AB. The time taken by both of them to meet will be the same. As the time is constant, distances AP and BP will be in the ratio of their speed. Now supposing a person starts from A in this direction and another person starts from B in this direction and they meet at point P. The total distance covered by these persons on the meeting will be AP plus PB, which is nothing but AB. So the total distance covered by them on the meeting will be AB. Now, since both the persons have started traveling at the same time simultaneously towards each other, the time taken by both of them to meet will be the same. That is, the person has taken the same time to travel the distance of AP as this person who has traveled the distance of BP. So time taken to travel AP is the same as the time taken to travel BP. Now since the time is constant, the distances AP and BP is dependent on the speed of the person. Here, if the speed is less, then the distance traveled is less. If the speed is more, then the distance traveled is more. Since the time is constant, distances AP and BP will be in the ratio of their speed. Now let's understand another important concept of meeting points. Let's suppose that the distance between 2 points M and N is D. If two people A and B are walking towards each other from M and N respectively, when they meet for the first time, they together cover a distance of D. When they meet for the second time, they together cover a distance 3D. When they meet for the third time, they together cover a distance of 5D and so on. Now let's understand this concept with the help of a diagram. Now this is point M and this is point N, and the distance between M and N is D. Now A starts from point M in this direction and B starts from point N in this direction, and they start walking towards each other and meet at point P for the first time. When they meet for the first time, together they have covered a distance of D. Now after meeting at point P, B travels till M and A travels till N, and together they have covered another distance D. So earlier it was a distance D and now one more D, so 2D. Now after reaching M and N, after reaching M, B turns back and travels in this direction, and after reaching N, A turns back and travels in this direction to meet again at point P. Now together they have traveled another distance D. So earlier 2D plus one more D is 3D. So when they meet for the second time at P, together they have covered a distance of 3D. Now after meeting for the second time, A travels to M and B travels to N. Together they covered another distance of D. So earlier 3D plus one more D is 4D. After reaching M, A turns back and walks in this direction, and B after reaching N turns back and walks in this direction, and they meet again for the third time at P. So again they have covered one more distance D. So earlier 4D plus one more D is 5D. So when they meet for the third time, they together have covered a distance of 5D. Hope you have understood the concept here. Now let's learn about the concept of stoppage time. A body covers a certain distance at a speed of v1 kilometers per hour without stoppage, and it covers the same distance at v2 kilometers per hour with stoppage. Then stoppage time per hour is equal to v1 minus v2 divided by v1 hours. This is nothing but stoppage time per hour is equal to difference in speed divided by faster speed hours. Remember this formula for solving stoppage time problems. Let's understand the concept of time taken with two different modes of transport. A man uses one or two different kinds of transport for going from A to B and back to A again. He has three options for the above journey. He uses fast transport both ways. He uses slow transport both ways. He uses mixed transport, that is, fast transport for one way and slow transport for the other way. So to find time gained or lost, use the formula time gained or lost is equal to time taken by any one transport both ways minus time taken by mixed transport. Remember this formula to solve problems on time taken with two different modes of transport. Viewers, please go through this video till you have understood all the concept. Please watch all our videos on solved problems on speed, time and distance for better understanding. If you have liked this video, please like, subscribe and share this video. Thank you.